Hey guys, today we're going to do a little bit more of verifying identities before we take our quiz. So remember, when we verify, it's easier to work on the more complicated side than the easier side. So on this example A, I'm going to go ahead and work on the right side of the equation. So we want to add these two fractions together, and if we notice in the denominator there, those two terms are, those denominators are conjugates of each other. And when we have conjugates, that usually gives us a little present of some Pythagorean identities. So over on that left side, I'm going to go ahead and add those two fractions together, so I'm going to have to get a common denominator. So I still have 2 cosecant equals. This first fraction will have to be multiplied by cosecant minus cotangent. And when we multiply out cosecant plus cotangent times cosecant minus cotangent, we're going to get cosecant squared minus cotangent squared. Plus, and then we'll get common denominators on the other side. All right. So now that we have common denominators, we can go ahead and add our numerators together. So we still have that 2 cosecant theta out front. Cosecant times cosecant plus cosecant is 2 cosecant. And then we have a negative cosine plus positive cosine, those add to 0. Over cosecant squared minus cotangent squared. So 2 trig squareds means we're going to have a Pythagorean identity. So the Pythagorean identity that has cosecant and cotangent in it is going to be cotangent squared plus 1 equals cosecant squared. So to get cosecant minus cotangent, we'll have to subtract cotangent on both sides. So cosecant squared minus cotangent squared is equal to 1. And then 2 cosecant squared divided by 1 is just 2 cosecant squared. Remember that your last step should have the exact same thing equal to each other. Cool, let's look at the next one. Now, this time we have some alphas in there with our verification. Remember, that's just like a theta or like an x or anything else. They look a lot more like A's when they're typed out, but my alphas look like little fishies. So just be ready for that guy.
So like I mentioned a while ago, there's a lot of power in conjugates. Conjugates will give us a nice present of a Pythagorean identity. So we have 1 minus cosine alpha down there on the bottom. His conjugate is going to be 1 plus cosine alpha. So I'm going to multiply that fraction by the conjugate of my denominator. So I'm going to multiply it by 1 plus cosine over 1 plus cosine. Now, I'm not actually going to multiply out the numerator. I'm going to keep it as sine of alpha times the quantity 1 plus cosine alpha over. And then you're more than welcome to multiply this out. But if you know how conjugates work, you know this is going to end up being 1 minus cosine squared alpha. All right, so we have a 1 minus cosine alpha, or cosine squared alpha down there in the bottom. That's screaming at you right now, I'm a Pythagorean identity. Remember, sine squared plus cosine squared equals 1. So that means 1 minus cosine squared is equal to sine squared. So this is why I didn't multiply through by that sign, because one of our signs here is going to cancel out. There we go. So now we have 1 plus cosine of theta, or I'm sorry, alpha. That's all over sine. So now we're going to take that fraction we have and split it up. So remember, to add together, they have to have common denominators. So before we added two fractions, we had 1 over sine alpha plus cosine alpha over sine alpha. One over sine is the same thing as cosecant. Cosine over sine is the same thing as cotangent. And now that sucker is verified. Awesome. Let's take a look at the next one. Now this time our variable is beta. But remember, that doesn't change anything. I'm just throwing in random Greek letters here and there to make sure that you're not afraid of different symbols. Just because they look silly and different doesn't mean that this problem is going to change at all. So remember, the first thing we're going to look for, especially on that left side, is a greatest common factor. The terms that they have in common, they both have one cotangent beta to give, and they each have one secant beta to give. So after we take out the cotangent and the secant beta from the first term, we're just left with cosecant squared beta minus. When we take out one of those cotangents, I'm left with cotangent squared beta. And then we factored out that secant, so we don't have to worry about him anymore. So now, right there in those parentheses, it's like, I'm a Pythagorean identity. I'm 2 trig squared. So cosecant squared minus cotangent squared. The Pythagorean identity that has both of these guys in it is that cotangent squared plus 1 equals cosecant squared. So we can subtract cotangent from both sides. And we'll see that cosecant squared minus cotangent squared is equal to 1. We just found out this was 1. So we took care of a GCF. We took care of our Pythagorean identities. Now we'll turn everything into sine and cosine. So cotangent is going to be cosine of beta over sine of beta times secant is 1 over cosine of beta. Then those cosines will cancel out, so I'm left with 1 over sine of beta. And 1 over the sine of beta is the same thing as cosecant of beta. So now he's verified too. All right, that's all of them. Good deal. See you guys later.